Hi, this is Ms. Fitzmaurice, and this video is an explanation of the free response number 5 that's on page 9 of your review packet. It is also a free response problem from the 1989 AP, meaning that when this was given as an actual AP test question, I was 1.5 years old. The first McDonald's was being built in the former Soviet Union, and in about 5 months, the Berlin Wall would come down. Okay, so in this problem, we have someone swinging a ball on a string above their head. So here's a rough picture of that. At some point, we know that the string breaks and the ball falls a distance h, so this person needs to be slightly taller. We also know that it is swinging at some radius r. Okay, and it's in a horizontal circle. So in part A, we want to know part I, the time required for the object to hit the ground, the horizontal distance it travels, and the speed of the object before it hits the ground. Okay, so in part I, we want to know the time required. We're going to use kinematics, and to find time, we really only need to worry about the y direction, the up and down direction. So I'm going to go ahead and make a list. I have x naught y, xy, v naught y, vy, ay, and of course I'm looking for t. So I know x naught is h. I know that xy, the final height, is the ground, so that's 0. The thing is moving around in a horizontal circle, so the initial up and down velocity also has to be 0. I don't know what this is, but chances are I don't care. And ay is, of course, -10, but it says to, show things in terms of g, so that's going to be -g. Okay, so we can go ahead and we see that the first kinematics equation is going to help us out. Xy equals xoy plus voyt plus 1/2 ayt squared. Okay, we know that xy is 0 as well as voy. And so we can just go ahead and plug in our variables. Of course, we have h plus 1/2 -g t squared. Okay, I'm going to move this whole chunk over to the other side. Okay, so I'm effectively adding 1/2 gt squared to both sides. I have 1/2 gt squared is equal to h. I'm going to divide both sides by 1/2 g. Okay, and when I do that, I end up with t squared is equal to h, except this 2 comes up to the top, so I have 2h divided by g. I take a square root, and I find that t is equal to the square root of 2h divided by g. Alright, so I have my time. Next I want to know the horizontal distance. So I'm looking for xx. You can probably guess I need to go ahead and make an x chart. Okay, so I have xx, xox, vox, vx, ax. And of course I know that my t is equal to the square root of 2h divided by g. Alright, so I know that ax is 0. I know that vox is this v naught that they tell us about in the problem. And so because there's no acceleration, my final velocity has to be that way too. I might as well say my initial x position is 0, and this final x position is what we want to know. Okay, so I'm going to go ahead and use the first equation again. Xx equals xox plus voxt plus 1/2 axt squared. Okay, xox is going to go away. I have 0. And so I go ahead and also cross out ax, which is also 0. I have now xx is equal to vox, which is just vo, times the square root of 2h divided by g. And that's the distance traveled. Alright, part 3, it wants to know the speed of the object. Okay, so not just Vx or Vy, but the total. And the easiest way to find this is by using conservation of energy. Okay, so sigma E naught equals sigma E. At the beginning, when this ball is moving around, it's at a height, so it has UG, and it's already moving, so it has K. So I'm putting little knots underneath these. At the end, it has no height, so it has no UG, and it just has kinetic energy. So I'm going to go ahead and I'm going to plug in 1/2 mv0 squared plus mgh equals 1/2 mv squared. And I'm looking for this final velocity right here. Okay, first I notice that I have an m in every term, so I'm going to divide both sides by m, and all of my m's are going to go away. And I've practically solved for v squared. I just need to multiply both sides of my equation by 2, so I have by 2, and when I do that, I end up with v0 squared, okay, 2 times 1/2 is just 1, v0 squared, plus 2gh is equal to v squared. Okay, the last thing I'm going to do is square root both sides, and I have v is equal to v0 squared plus 2gh. Alright, so part B, it says on the figure below, and we just have a dot, draw and label all the forces acting on the object when it is in the position shown by the diagram above. Okay, so of course we have gravity going straight down, and then you ask yourself what else is acting on this ball, and the answer is the only thing acting on it is the string. So we have tension, Ft or T, either one is fine, going up as a diagonal. Okay, so that's it for part B. Part C, it wants to know what is the tension. So we want to find an expression for Ft, and what we have to do is we have to use Newton's second law both in the x and in the y direction. Okay, so in the x direction, we know this thing. If I were to draw how it's moving, we know this thing is moving around in a circle, and that its acceleration has to be towards the middle, and so ax is really ac. Okay, so we have ftx is equal to m times ac, and ftx equals m vt squared divided by r. And that vt is just v naught that they gave us in the problem. Now in the y direction, I'm going to show you ftx and fty. In the y direction, we have fty minus mg equals may, but it's not moving up or down at this moment, so ay is 0. And we end up with fty equals mg. Now, I could go ahead and do a bunch of geometry with sines and cosines to find a number for ft, but I know that in general, this thing right here that I'm outlining in red is a triangle, and that the Pythagorean Theorem applies. Actually, I'm going to get rid of my red, but I know that ft squared is equal to ftx squared plus fty squared. And so I can solve for ft just using this, since I already know ftx and I already know fty. Okay, so I'm going to go ahead and I'm going to write ft squared is equal to ftx squared, which is m v naught squared over r squared, plus fty squared, which is just going to be mg squared. Now I can take the square root to solve for ft, so I get ft equals the square root of m squared v naught to the fourth divided by r squared plus m squared g squared. And if you wanted to, you could stop there, or you could factor out an m from each term and write down ft is equal to m times the square root of v naught to the fourth divided by r squared plus g squared. Alright, so in terms of point breakdown, for a letter I, you get 1 point in total for solving for the right answer. For II, again, you get 1 point in total for solving for the right answer. For III, you get 1 point for indicating that energy is conserved, and 1 point for the right answer. For B, you get 1 point for FG and 1 point for FT, but if you had anything extra, so for each extra force you lose a point, down to 0 for part B. So you can get 2 points maximum, but if you had like Fn, for example, you lose a point. Now in part C, this is worth 4 points in total. Okay, so you get 1 point for just writing F equals ma. You get 1 point for ftx, or f cosine theta equals mv squared over r. 1 point for fty equals mg. And you get 1 point for solving for the right answer. It doesn't matter whether you have it like this or like this, as long as it's algebraically equivalent, you're good.